So, welcome Abimbola on board to facilitate the session on understanding smart contract and how it works. So, over to you, Abimbola. Thank you.
Okay, thank you so much for having me. I really appreciate it. I've known Mr. Tunishi since I think 2018. It's been a long time coming. Thank you so much for having me. So basically, I'm a blockchain developer. So I work on I started with like working on EVM. So but currently the stack I work with at the moment revolves more around Bitcoin, Clarity, building smart contracts on Bitcoin and doing some protocol stuff. So I'm happy to be here to help you get a bit of understanding around the smart contracts, and we'll try to go in deep as far as we can go today. So it's going to be an interactive session because we are going to have some practicals to do very soon. So let me just share my screen now. Just a minute. Okay. Please, can you confirm if you can see my screen? All right. Thank you. So, firstly, I believe by now we all have the background knowledge of what blockchains are about. So, smart contracts are just basically computer programs that target a blockchain. What this means is that the same way you have on your phone, you have several applications that you are using currently. And you will note that, for example, we have the Android, the Play iOS application store. You know that sometimes the applications that work for you on Android doesn't work for you on iOS and vice versa. And this because those computer programs are meant to be executed within a certain environment. That's why it's like that. So that's why, for example, the way you build applications on for Android is different from how you build application targeting iOS. It might be the same functionalities, but for example, it can be different in terms of the programming language you use and stuff like that. So for smart contracts, they are just basically computer programs that are meant to be executed in the context of a blockchain. So, sorry, before I proceed, uh, please, is everybody just aware with like the primitives of blockchain, like the blockchain basics, how it works, before I move into smart contract?
Sorry, you come again.
Like, is everybody here aware of like blockchain, what blockchain are like,
Yes,
just
yes,
the
yes,
basic
we are
concept?
aware.
Okay, thank you.
The vast
All
majority of
right.
those people are aware. Yeah.
Okay, thank you. So now, firstly, we have in the issue of like blockchain innovations, we have Bitcoin. Bitcoin as the most popular one in terms of like the one that first got noticed by people before you now have. I'm going to use Ethereum to explain some of the concepts. So everything you need to know about smart contracts, once you understand it, how it works on Ethereum, you can actually translate them to different execution environments, to different blockchains. So one of them is that on Ethereum, there's this thing called user account type. And we have the smart contract account and we have the externally owned account. The externally owned account is the one that is being used by users, the one that you generate from your wallet, where they say, store your seed phrase and keep it safe. Store your private key, don't reveal it to someone. that kind of account model, anything that involves wallets, seed phrase, private key, and public key as it relates to like blockchain environment, those ones are usually referred to as externally owned accounts, in short, EOA. Then we now have this set of another type of accounts, which are called smart contract accounts. Smart contract accounts also are similar to the normal addresses you have. The only difference between them is that they have some logic predefined in them, which determines how they behave and how users can interact with them. So that means smart contracts define rules and automatically enforce them. So it means that as long as you satisfy the condition of that smart contract, whatever it is that you send that's in the configuration of that smart contract can be automatically enforced without the need of any intermediary or someone to just come and check it for you anytime you want to like run it. So what are the characteristics of smart contracts? One is that smart contracts are immutable. We have this concept called deployment of smart contracts. Deployment of smart contracts basically just means creation of smart contracts. And I'm going to go into the logic of that very soon. So once you have a smart contract and you deploy them on chain, on any chain, let's say you deploy it on Ethereum, for example, you can't modify that contract after deploying it. So everything that users need to do on that contract has to be based on what you've predefined before deployment. So that's part of the reason why you see that, for example, Uniswap that we all know, you've heard of Uniswap v2, Uniswap v3. In regular software development, for example, we all use Facebook or Instagram. The Instagram that you are using currently, how it looks and how it operates is different from Instagram of like 5 years ago. There has been changes in the UI, how you interact and stuff like that. But you are not aware of that because that one, it is a mutable kind of program. But when you come into the context of smart contracts, it is immutable because of the transparent nature of blockchain. So if you need to like have an upgraded version of your contracts, of the functionalities that you have, it has to be a different smart contract entirely with a different contract address. That's part of the reason why you have like when you are interacting with a decentralized exchange like Uniswap, there's Uniswap v1, there's Uniswap v2, there's v3 currently, and v4 in development. So that's what you need to understand about that. I think I saw someone with just give me a moment. Once I'm done with this slide, we are going to, if you have any question, we are going to solve it before we move on. So the next thing is that smart contracts are meant to be deterministic. And what that means is that the outcome of execution of a smart contract is the same for everyone who runs it, regardless of your location. It is not like, for example, most of us that are Nigerians on this call, you probably be aware of the time where we could not access Twitter because of location. That doesn't work with smart contracts. You can't be blocked from using smart contracts because of your location. So as long what happens for someone who is black when they pass in a certain input is also going to be the same thing as someone else. So there's no segregation of, oh, this is how it should run for this person. It's the same thing for everyone. So the next thing is VM context. And this VM context is basically virtual machine. So what I mean by this is that each smart contract targets a certain execution environment. So for example, we have Ethereum and EVM chains. So on Ethereum, basically, if you want to write your contract, you write it in Solidity, and it targets something we call Ethereum virtual machine. So this Ethereum virtual machine is what handles, is like, let's say, the brain of the EVM, the brain of Ethereum is what we call EVM, which is Ethereum virtual machine. This virtual machine is just like a computer that handles instructions based on how new changes to the state should be recorded and how it should move from one state to another. So each Ethereum, when it started, claimed to be the some of the unique proposition that they said was that they are meant to be the world computer, that is, be able to like bring people on chain to handle any infrastructure, anything they want to do on chain. So in this world computer itself, so every system you see, every for example, your phone itself has the machine, the operating system, so which is what we separate as Android OS or iPhone OS operating system. These are basically like what enforce the rules that should enable the execution of these programs within the context of that environment. So, for example, how you write the rules for smart contracts on Ethereum is different from the rules of smart contracts on Polkadot. It's different from the rules of smart contracts on Cardano and like that. So these different blockchains, more specifically, those that use different languages, target a different virtual machine. So when you have, so smart contracts is not just limited to Ethereum alone. So anywhere you see this smart contract, the virtual machine is what handles this state transition from one state to another based on how transactions are being executed. Just know that, okay, when you want to like change the state of a blockchain, you have transactions change the state. So combination of transactions and what is being included into the blocks. So the blocks linked together is what makes up the what we now refer to as blockchain. So I know probably that's been a lot, but before I move on, is there anybody that has question or you need clarification on something that I've touched on now? You can drop your question or maybe drop it in the chat or mute your mic. Or are we all on the same page?
Yeah, you can just react if you feel you don't have a question and it's good to go. Something like this. Okay.
Okay. All right. Thank you. So the next thing will be the life cycle of a smart contract. So how do these smart contracts work? So it's when you go in details, it's actually like more technical than this, but this is just like a high level overview of it. So the first thing is when you want to have a smart contract, you write the smart contract in a language of choice. And this language of choice, it depends on the virtual machine that you are targeting. So for example, why is it that people that know JavaScript, you can't use JavaScript to write smart contracts on Ethereum? It's because JavaScript cannot target Ethereum virtual machine. Going back to the thing that I mentioned earlier about the VM context. So the virtual machine that you are targeting, the blockchain that you are targeting, determines the kind of programming language you use to write smart contracts. So for example, on Ethereum and most EVM chains, what you need is Solidity. So Solidity is what you use to write smart contracts. Please, there's an interference, Samuel. Okay, thank you. So that's it for Ethereum. But let's say it is Polkadot now. for Polkadot, you have to make use of, on this stage, this first part where you have Solidity, you have to use Rust. For on Bitcoin, for example, let's say Stacks L2, if you want to write smart contract there, you have to use Clarity to write the smart contracts here. So now, this Solidity language, it is something we call a compiled language, which means that there's a process between the high level version in which humans can understand to the one that the virtual machine, the computer understand more. So that's why you have the compiled language. So the compiled language means enables you to bring what is more Solidity is more human readable, but the virtual machine itself, the Ethereum virtual machine, cannot operate directly on the English in that code. It needs to convert it to zeros and one and some hexadecimals to be able to like operate on it. So that's the process of turning that high level code in which the programmer humans can understand into a more machine friendly manner is the process of compilation. So this happens with Solidity. And what happens is that when you write your Solidity, you need to generate a byte code. So this byte code is what is now being stored on chain. So this byte code is what represents the instructions that have been encoded into that smart contract. So the next step is now deploying this transaction, this contract. There's a special kind of transaction which we call creation transaction. So the difference between this transaction and just maybe me sending money to another person on chain is that when you want to deploy a contract, the contract doesn't have any address yet. So in the process of deployment, you are storing the code that you've compiled on step 2. You are storing it on chain and also having a contract and contract address attached to it. What that means is just like having a public address that anybody can use to interact with this smart contracts. That's what it means. So what separates this deployment transaction from a normal transaction is that this transaction, the toll. So for example, a normal transaction now, let's say I want to send money to Mr. Tumishi. I will be the from address. Mr. Tumishi will be the toll address. So if I send money, the toll address will receive it. But in the context of deploying a new contract, the toll address has to be something we call address 0. So this address 0 is a programmed address. And what it does is that it accepts, so it has 2 functions. This address 0 is also the same thing where when they say they want to burn a token, that's the address that it's being sent to. When you say you want to like reduce the circulating supply of a token, it is actually most of the time being sent to the address 0. That address 0 doesn't have private key and doesn't have code. It is just meant to accept. So address 0 is something that accepts but can't give out. So very soon, by the time we get to the demo section, we are going to look at address 0 itself and see the amount of money that has been burnt there that nobody can have access to. So this same address is now where you put, when you are deploying transaction, that will be the toll address. So because when you now send that transaction, it analyzes it and see if it is a contract, if there's a contract code attached to that transaction, it will now deploy it, it will compile it. The byte code that you send will now be stored on chain. And this byte code is now what people will interact with. So the virtual machine now interprets it based on the rules that have been defined in the smart contracts to now interact with them. So from deploying this contract, a contract address is generated. So from there, any other interaction that you want to do, let's say you want to, let's say it is a decentralized exchange now. So how it goes is your decentralized exchange protocol, you write it in Solidity. The Solidity is the one you understand, the programmer understand, everybody, once you read it, it's written in, it's a programming language, but it's actually basically English language. So this decentralized exchange protocol that you have in Solidity is turned into bytecode. This bytecode is basically zeros and one, hexadecimal, basically zeros, one, then A to F. So we are going, if it is not clear now, just give me a moment. By the time we get to demo and we look on chain for some transaction, we see what I mean by that. So after that, you now deploy this decentralized protocol that you are, this decentralized exchange protocol that you are building. You deploy it, and a contract address will be generated for you. So anybody that now wants to like make use of your protocol to exchange tokens, it is that address that they will be interacting with. If they need to send a function call, if they need to buy token, send token, that's the one that they will use. Okay. Are all smart contracts open source? No, not all smart contracts are open source, but all smart contracts are deployed on chain, which means they are available to people. So the difference is that we have something called verified contracts and unverified contracts. By the time we get to demo, that one will be clear. I will make sure I show you some of these things too. So if I can miraculously crack address zero code and take out all those assets and it, yes, so but it's not possible. It's part of the it's not possible, honestly. Yeah. Okay. So before we go into demo, is there any concept that is not clear from what I've explained before? Before we go into the demo part. Okay, you missed on address zero. So basically what I said is that this address zero is a special address. This address is where, when you say you want to burn token, that's the address that is being sent to. So when you that's reducing the circulating supply, total supply of a token, doesn't, once it has been minted, it doesn't automatically just disappear like that. It's just being sent to an address that it can't go out from there, and that address is address zero. So, and this same address zero, and apart from the functionality of like handling bond tokens, it is also the same address that enables you to be able to like create new smart contracts. So when you want to create new smart contracts, the target environment, the target address is this address zero. Okay. Is it clear now? Okay. Thank you. Any other question? All right. So let me stop sharing the screen. Let me see if it will work. Sorry. How many of us have used Etherscan before now to just like analyze transactions?
So we've actually walked everyone through on how Etherscan works. But yeah, coming from you would also be more interesting.
Okay. All right, thank you. So firstly, I'm going to just like pick two different transactions now and show us some things. So let's pick this latest transaction. So one of the things that I did not mention earlier was that one of the things that separates a smart contract account and an externally owned account is that at no point in time can a smart contract initiate a transaction. Smart contracts will always just react to an initiated action from an externally owned account because they don't have public key and private key, which are used to sign messages. It is externally owned accounts. What you do from your wallet, it's only you that can start that chain of reaction. Even though smart contracts can communicate with each other, but these smart contracts communicating with each other, it has to start from somewhere. And the origin, what we usually refer to it as ts.origin, which means transaction origin. So this transaction origin must always be an externally owned account because it needs a signature. That's just basically it. But so externally owned accounts, which means account that has private key and public key, can always initiate a transaction. But a smart contract can never initiate a transaction. Okay. So now, this from when I'm not going to, I think some of these things have been covered for you guys already. So this from,
You can
this
just go
0s,
back if you want to.
okay, all right. So let's start from this part. This tab that you have transaction hash. Sorry, is it clear for everybody or I should zoom in?
Yeah, you can zoom in.
Let me know when it's okay.
It's okay.
Okay, all right. So this transaction hash, what it means is like it is unique ID for each transaction that you have on chain. Every transaction that you have has a unique ID. Let's say I sent money to Mr. Tumishi, I sent money to Mr. Samuel and Mr. Kayode. How the blockchain will be able to know this different transaction is through the transaction hash. This transaction hash is a unique identifier. It is a combination of different things, which include the nonce, the account address being hashed together to generate this transaction hash. This transaction hash, even though it looks gibberish now, it is a combination of different processes that led to the creation of this. And the status of this part is when you know if a transaction has been successfully mined or not. Someone is saying they can't see my screen. Is it the same for everybody?
You can see your screen.
See your screen.
Okay. All right. Thank you. So probably just try to rejoin. So, and the next part is this transaction action. So transaction basically are stuff that you send to a blockchain to change the state. So every blockchain have this concept called what state. The what state is the current state of a blockchain at the moment. So every transaction that you send to a blockchain changes the what state. And this what state is basically addition of new transaction because the what state, everybody on the chain is available to see it. So with the addition of new transaction, each node on the chain needs to be aware of those stuff. So we are going to come into like some of these different types of transactions later on. So, but for now, let's look at this from. This from is an externally owned account. It cannot be a contract account. So let's look at this, and you will tell me one thing that. So this is the from address on that transaction. I want you to take note of this area, this tab from transactions, token transfer, NFT, and this thing. Take a careful note of this. There's going to be difference between this and the toll address of that one and the contracts. So just take a mental note of this. Now let me pick a, I think this should be a contract address. Any individual contracts. No. Okay. So let me just pick from here. Okay. So look at this. I think there's no way I can split this screen for you to see. But can anybody notice any difference on this transaction, internal transaction, token transfer part that was not on the EOA side that we went through? Just look at this. Let me pick another from, which is EOA. This is an EOA account. Look at what's here. They look at from the transactions part to the card part. This one EOA, and this is for a smart contract account. What's the difference between them? Yeah, the contract tab and the event tab. Let's go back to an EOA. Here, there's nothing like contracts and there's nothing like events. Well, if you go to this one, you have the contract part and you have the event part. And this is one, when it comes to like this Block Explorer, this is a very good way for you to easily know if an address is a smart contract or if an address is an externally owned account. So the events are basically like emitted from the smart contracts. So these events, most of the time, it is not always available to on every function, but it's advisable if you are a smart contract developer that every function that changes that modifies your smart contracts, that modifies the state of your smart contracts, you have an event emitted so that it can be easily tracked for you. For example, I don't know if you guys make use of like maybe subgraphs or anything like that. So this, when you use subgraph, what you are tracking is actually this event emitted. So if as a smart contract developer, you don't emit some events, those transactions will happen, but it will be hard for analytics like on-chain analysts like you guys to be able to track it, either even using like drone analytics and stuff. So it is always advisable that any major function that you have in your contract that changes the state of your contract, you usually have events, emit events to state, okay, this is the variable that was changed and stuff like that. Yeah. So now, on this contract part, what you have here is the Solidity code. And take a note of this thing. You on the contract part, you are seeing a check mark. This check mark means that this contract is verified. That is, the people that deploy this contract make the code open. I'm going to show you guys an unverified contract now, and you note the difference. So this one, I can see the different functions that have been defined here. So everything you are seeing here are what enforces the rules that enables all these transactions that you see here on the transaction tab to be able to be successful. Because look at it, the transactions are coming from an externally owned account. They are all routed to this contract address. So without this contract, some of the functions that you are seeing here. So for example, this part where you are seeing method, this method are the different functions that are registered on this contract that the user is calling. Are we clear? Okay. All right. So now let me look for another unverified contract. Let's use contract. Is this a contract? Okay. There used to be a tab here that we can actually just see unverified contract. But since they've removed it, this one is a verified contract. Let me just quickly get one address. Just a moment, please. Okay. Just a moment. I've seen it. So let me paste it here. All right. So look at this too. You have contract here. But this contract, it does not have the green check mark like the previous one that we've seen. So this one, look at what you have here. What you are seeing here, these numbers, and if you look at it, earlier on, I said that the Solidity code that you wrote, it's going to be compiled down into bytecode. What you have here is bytecode. And these bytecode are basically hexadecimals. So it will consist of values between 0 to 9 and A to F. So looking at this now, let me zoom in a bit. Look at what you have here. There's no way you can see anything like G or H here. So this thing that you have here, this is an unverified contract. So for the person asking if all smart contracts are open source, so in this context, now you can say that this one, we can't exactly see what the exact thing that this person wrote here. Yes, you can compile this bytecode, but it won't give you exact thing that's done to this. It will just try to like compare what the bytecode with some previously deployed contracts on chain and see if there's any similarities between them. That's just it. This is an unverified contract. So anytime you see a contract in the contract tab, like this one now, that has a check mark, it means that contract is verified. And you can see the source code that is being used to that is operating on that address. If it doesn't have a check mark, it means it is an unverified contract. So part of the things that I used to evaluate the trustworthiness of a project also is if they have a verified contract that everybody can look into, or because this one, you can actually have a function there that allows you to steal users' money. Since it is not open, people can't really see, and they just have to do trust me, bro, That's part of the challenges there. But still, it is not all contracts that are verified for different reasons. But these are some of the things that you need to know. And looking at this too, this is a contract. And the previous one that we checked, there was a part of event. On this one, you are not seeing event. So how are you going to be able to like track what's going on in this contract? So, okay, this one is just a token actually. So this is an ERC20 token contract. So how do I know that? It is by looking here. So look at this other info part. This is the token contract with 9 decimals. And you can see this is the total supply. This is the number of orders, and this is the total number of transfers. So this so for each transfer that has been happening, they did not emit any event in this contract. That's why you are not seeing anything like event tab here. Does it make sense? If you have any question, you can unmute your mic at this point or drop it in the comment section. All right.
All right. To help you create more organized question and answer session. So if anyone has a question, they can just raise their hand, just like I do. Right?
Okay.
So yeah, you can then call them up. So if you have any questions, use up your hand. Thank you.
Okay. All right. Okay. All right. Chinon, so you can go ahead with your question.
Okay, I hope I'm audible enough.
Yes.
Okay, thank you very much for all this. I want to ask, you said there is no event being emitted by this token contract, and I want to ask, is it the same for every other token contract that they don't emit events because it's a token?
No. So let me pick another contract. So on this part, we have top ERC20 token. So let's look at Tether. No, I think this one doesn't work. So, and else is there. Which one? I'm not certain of the missing things. Perhaps BTC. Yeah, I'm coming. Usually, let me show you so that's not the reason why they are not showing, because when you are writing ERC20 token contracts, any contracts, there are usually events emitted in them. So let me I'm trying to just give me a moment. Let me see if there's one that I know that I can easily get. Okay. I think there's another block. Let me check block scout. So probably this is part of the configuration, the new update on Etherscan. Let me just check for another transaction. The scouts. Tokens. There. Yeah. So this is transfer. Okay. So on this one that is not showing, let me just even go to the parts where they have events emitted in the contract so that you can see. Let me go to USDT. It's a verified contract. So it's not this part. Tokens possible. They don't have events defined. Okay, they have actually event issue. Which of the selected version is this? Sorry. Uh, okay, this is part of the older version. Okay, let me see if there's a new one that happens. Bitron will say that some want to this was 0.74. I think so. For example, looking at this transfer from emit, let me just search for emit in here. Emit. So what you are seeing here, this keyword emit is what we use in smart contracts to indicate to the to enable that once this function call is done, emit an event. I think the reason why we are not seeing those events on this part is from Etherscan. So like at least from this one, you can see that there are different parts of emission of events. But for some weird reasons, I don't know why it's not showing on Etherscan. I used to be able to like even read events for contracts before, but I don't know what's happening. See. Oh, okay. All right. So look at what happened now. I think I'm the one that missed it. So this part, this is the GRT token. So for some reasons, I think Etherscan is just giving you a smaller analysis of the transactions here. So all you just have to do is click on the token contract here. This one on this tab, just follow my cursor. Clicking it, I can see this is the contract of the graph token. This is the transactions. This is the events tab. So those transfer functions that you are seeing, these are the events emitted from them. So if these are some of the things that you can actually create, maybe subgraph, or I don't know, some of this analytics stuff, you can create it for them. So let's do the same thing for USDT to see if we are going to see them. I think this is a new update. Usually before, the moment I click on this Tether USDT, I'm supposed to be able to like see everything once. I think it's because of all this different stuff that they have here. So clicking on the token contract, I have it here. So that's just, I think, 2 steps now to be able to get it on the coins version. Okay. So that answers the question that are event missing in the contract if it is unverified. There's no way the blockchain can decode it most of the time. So, the reason why you are seeing this one, all this contract code and stuff, is because this source code was verified. If it wasn't verified, what you will just see is hash code. So each function call event has something we call function signature. So it is only when you make them available that the Explorer will be able to decode it. For example, looking at the events tab here, this transfer that you are seeing here, it's because you're able to decode, tell that this is a transfer event because the code was verified. So even if this code was not verified, the Explorer will record that the event was emitted. But without the source code, there's no way to say that, okay, this is the name of the emitted event. Does that answer your question? I think today, data today. So. Okay. So now, examples of events like swap. So let's look for Uniswap. Let me see if uh, yes, this is Uniswap. Which is this the right address? I doubt it. This is not the right address. Let me just look for the original Uniswap address. Some 50 address. Okay, deployment. Okay, just a moment. I'm trying to get some of the address from Uniswap website. Yeah. Okay. Yeah. Unet. So just a moment. Now, I got this address from Uniswap documentation for this is for V2, one of the contract deployments on V2. I'm just going to quickly do that now. I don't know why it's loading slow. That's giving me a bit of time. Yes. So can you confirm if you can still hear me? I don't know if it's my network or something.
Sure, I can still hear you.
Oh, I don't know why it has kind of loading. Okay. I didn't stop. Let's go to this here. This is strange. This site is usually faster than this. I don't know. It's very slow. Um, so can you hear me now? I think I lost connection at some point.
Yeah, I can hear you now.
Okay, thank you. So I don't know
Yes,
why.
can hear you.
Okay. Just give me one experience trouble 2003. So this contract now, any this address is what we call Uniswap V2 factory. Yes. So every pool you see, every trading pair that you see on it on Uniswap, they are being deployed there. This the contract that you use to deploy them. So like let's say you have this part of USDT to RapTTH, USDT to BTC and stuff like that. This if you need to create a pool, this is where the transaction happen. So once all this one you are seeing here are to create pair. So let me just pick one of them. So this one, let's pick the latest one, create pair. So this one, create pair. Let me see the yeah. Let's just see. Let me just get on that one pool directly so that we can see the event for swap. Okay, full addresses. Send the one for ETH and DAI. Yeah. Let me stop presenting this. Then bring it here. Okay. So this address currently that you are seeing now, this is ETH and DAI Uniswap pool. And here is it. The token worth here is $1 million that is locked in this contract for this pool. And let's go to the event. You can see all this one withdrawn, reward paid. Let me see if there are some for swapping. When was it last one? So this emitted event, it's showing event for people providing liquidity as they are withdrawing their liquidity and getting their reward paid. That's what we are saying here. So this is similar to other Uniswap pools that you are going to see that you interact with directly. So this is the let me get the so most of these addresses, as I'm talking to you, I'm just like trying to get them from Uniswap documentation to paste it here. That's just like what I'm doing. Okay, thank you. All right. So the is Etherscan only used to explore? Yes, Etherscan is majorly used for Ethereum. It's only, sorry, I mean, it is only used for Ethereum. So if you need to check a Polygon, it is Polygon scan. So most of the blockchains replicate that, just adding scan to it, scroll scan and stuff like that. But there has been, so like for example, when I was trying to check that event thing that we had issue with, I went to check Block Scout. Block Scout is also another explorer. So Etherscan is not the only explorer, but it's the most popular. And it's because like compared to others, it's still easy to get some certain informations about transactions and details like that on this. Yeah. So, okay, now let me look for address 0. Let's see how much is there. This one is ETH DAI swap pool, and you have this amount. So let me look for the address 0 on Etherscan. So, and sometimes there's also Z address too. Just a minute. Let this go. Yeah. All right. So, um, this is the address 0. Let me paste it to the chat. So just like you have your normal address, this is how the address 0 is. It is a custom address. And look at the amount of ETH that it's here, 13,398 ETH. Not to even now talk about different token. So look at it. These are some of the tokens that are burnt. So as you are burning tokens, this is the addresses that it goes. There's also the dead address too that they use, but this is the standard. So all this amount that you are seeing here, it can't be circulated. People can have access to it the moment it gets here. So that's it. I think so let me switch to the slide. So demo and okay. So I'm going to stop sharing this screen. Let me share this one. I think this one. All right. So we've done demo. So some of the trends you need to look out for is account abstraction and smart wallets. So this, I've mentioned that there are majorly 2 types of accounts: the externally owned accounts and the smart contract account. So this account abstraction is just trying to there are different implementations to it, and you don't necessarily have to bother yourself about it at this point, but try to understand them to some extent. So another one is meta transaction. And what is meta transaction? This meta transaction is that, these days, currently, if you don't have gas fee, you can't perform transaction. So meta transaction is a way that enables someone to be able to pay for your gas fee on your behalf. So you sign the transaction, but someone else pay for the gas fee. That's just the logic behind meta transaction. The next thing to look out for is also upgradable contracts. Remember earlier when I was describing smart contracts, I said they are immutable. There's this concept that we use in smart contract development. It's kind of tricky, but you can still retain the address, but with different functionalities. You are not really fully changing the state, some of the logic behind it, but it gives you way for little upgrade. And another trend to look out for is multi-VM paradigm. What that means is that earlier I said you can only use Solidity to write on EVM, but now Arbitrum has this thing called stuff called multi-VM, and it means that they enable you to be able to use Solidity and Rust to write smart contracts. And some things are also trying to work on this too, to make things easier for people. So that's majorly some of the trends to look out for in terms of smart contracts. So now, if you have any question that you want to ask about smart contracts that I've not touched in the previous things that I've covered, or anything that's not clear, please, now is the time to ask. Thanks for. Okay, I think there are some questions in the chat box. It can be used for anything. So this the address 0 only knows how to collect. It doesn't know how to give. You can't. So that address 0, look at the way the address is. It is very custom. You can't. It doesn't have private key. It is part of something. Some of the things that were created with the chain. So it is a feature in itself that allows for all this modification to be possible. Nobody can access it. So if it is, had it been like it is, so it's just like smart contracts now that, smart contracts can initiate transaction, but they can react based on the code attached to them to any stuff. But this address 0, it doesn't have private key and it doesn't have code. So there's no way for you to validate a transaction to. The only thing it knows how to do is accept either native currency or tokens, NFTs, like that. Yeah. So as a smart contract dev, when you want to make a transaction and copy the address, and this address you sent, no, there's no way you can retrieve it, even if it is the first transaction, because if it is some of the address, it is okay. Let me explain how these addresses are generated. So these addresses that you see, they go through different processes to be able to generate. And these processes are cryptographic processes that they are usually referred to as one-way function. So let me just quickly explain the difference between like encryption and hashing now, for example, for you to be able to understand this. Encryption is like what happens with your password. Encryption is basically like, let's say my name is Ade. If I encrypt it using Moon algorithm, it can turn it to another thing. So if I have the right passkey, I can decode it, and to be able to, when you decrypt it, you'll be able to get the Ade that was used to generate it. But hashes, which is what is used to generate these addresses, it is one way. You can only generate something, but you can't see what was used to generate it. So you can see the results, but you can't know what was used to get the results. That's part of the reason why it is, when you send money to a wrong address, if you don't have the private key of that address, it is not possible for you to compute it in any way. So people have tried it, but we have this thing called I think vanity generator to like try to generate different addresses, but some stuff, so you have to like find a way to get those numbers right, which is somehow impossible to do easily. So that's part of the reason why currently people are saying that quantum computing is what can break cryptography. So it means that when you have quantum computing, some of these things can be broken. So which is a threat to what we have currently explored on the blockchains and stuff. So that's majorly it. Yeah. Yes, tokens there are wasted. Yeah. So proxy contracts are one of the upgradable forms of upgradable contracts. So they are a different type of upgradable contracts. So what those proxy contracts means is, say, Mr. Tumishe now send me to go and represent him in an event. I will speak in that event on behalf of Mr. Tumishe. In the context of proxy contracts now, there's a target contract and there's a delegate contract. What this means is that delegate contracts act on behalf of target contracts. Okay, I don't know if I should go deep into this, but Proxy contracts are just another form of upgradable contracts, and upgradable contracts is quite a dicey topic. So, but if maybe we need to do some more stuff on that, we can probably, I can get materials to send to you, or we do another session on upgradable contracts, because you have under proxy contracts, you still have transparent proxy contracts, you have UI UPS contracts, and you also have another one that is called Diamond Standard. So it's a long topic on its own. So we can cover that. Maybe I can send materials, or we do it on a later date. The concept behind account abstraction. The concept behind account abstraction is just it is not fully formed yet, in terms of like they are not, the working solutions that you have currently are not that much. But the idea behind account abstraction is to prevent some of the problems that people are facing currently. For example, we have private people losing access to their funds because they misplaced private key. So some of the accounts, things that account abstraction aim to like solve is like, what if you can use social login instead of just like finding a way to store seed phrase and always keep it safe and ensure that nobody have access to it? What if you can just use social login, or you can find it just like the way you have multi-factor authentication on Web2? If you can have some of those paradigms also work for Web3 accounts, signing, accounts generation, that's of like the thought behind the account abstraction. So there are now different forms in which like people and projects are trying to like achieve it in their own way. I don't know if that makes sense, Joseph. Does that answer your question to 11? All right. Okay. So is there any more question? All right. I think that's all. Over to you, Mr. Tumishe. Thank you so much for having me. Shit.
Wow, thank you so much. Thank you, thank you. Please let's appreciate him. Yeah, thank you so much. Really do appreciate you for your time and for unveiling so much to us. Thank you. So really quick one. Now that we've learned so much from our speaker, yeah, it's time for us to just do a little support. Yeah, I'm gonna drop his Twitter handle on the group, the link, so that we just go and follow him right away. So, I mean, I would love to see us follow him right away from here. Okay. Let's give him a follow and let's, support him in the things he's doing. So, thank you so much, Abimbola. All right. So you can stop the recording. All right.